Okay, everyone, let's continue to cover the concept of thermochemistry in problem number 4 of 2024 free response problem. So we are given a coffee cup calorimetry, a simple calorimeter to measure the temperature of a change and then determining the specific heat of a specific metal, certain metal. Okay, so when you add a metal cube, 98.1 grams, heating up in a boiling water, 100 degrees C. We add this one to the water at room temperature, 25 degrees C, 52 grams of water, and then the temperature was changing. So we are measuring the temperature usually every 30 seconds and determining the highest temperature. It'll be eventually cool down, because the heat will be lost to the circumstances, to the environment, to the surroundings. Okay. So in this one, it is very important to read the highest temperature properly. Thermometer is given here. And we see that the thermometer is in between 38 and 39. So the temperature must be 38 point something. Remember, the last number must be our estimation. My estimation is 38.5 degrees C. So then last number is uncertain. This one is my estimation, estimated. It is very important to read the equipment with this properly. And when the final temperature is given, now let's draw the particle level representation of water molecules before and after the metal cube was added. So initially the temperature was 25 degrees C. Now after the metal cube, hot metal cube at 100 degrees added, the temperature water increased to 38.5 degrees C. And high temperature goes up, meaning kinetic energy increases. Kinetic energy is a form of thermal energy, related thermal energy. As kinetic energy increasing, then average speed of particles increase. Speed goes up. So then here is representing the vector. The speed is the velocity of each particle. Water molecules represent vector. And then it'll be make it bigger. Simply, the direction doesn't matter randomly, but should be longer than previously. Okay, and assuming the metal transfers 2,940 joules of thermal energy to the water. So this one is heat, and the metal lost heat. Q equals 2,940 joules. Energy, the unit is joule. Because the metal has lost heat, its thermal energy decreases. So let me put negative there. And calculate the specific heat of the metal in joules per gram Celsius. So let me bring up the heat equation. Q is equal to mass times specific heat times delta T. Q equals mcat. And here mass is given, mass of the metal is given as 98.1 grams. And specific heat is also given. This metal specific heat is okay, not given. And then delta T is final temperature minus initial temperature. Because the metal is the metal is added to the water, this is in thermal equilibrium with the water. So then at the end, the temperature water will be, when the temperature water is hitting the highest point, at that point, the why it is the change in the receiving the temperature is hitting the highest, because at that time the thermal equilibrium is established. So then the temperature of the metal and temperature water at that time is equal. Okay, so final temperature is same as the temperature water, 38.5 degrees C, and initially the temperature given 100 degrees C. So let's do this calculation. It is negative 61.5 degrees C. Now we are ready. So using this information, let's rearrange this heat equation. Q equals mc delta T. So C is unknown, so let's divide by both inside by m delta T. M delta T. So mass cancels out, delta T cancels out. Now specific heat is amount of heat Q over m delta T. Now let's plug in those values into the equation. Q equals negative 2,940 joules. Mass is 98.1 grams. And delta T is negative 61.5 degrees C. Then negative, negative becoming positive, and the unit is joules per gram Celsius. So it is joules per gram Celsius. So when you have 1 gram of material, raising the temperature by 1 degree C, it requires how much energy? That's the definition of specific heat. When you plug in, we find that it is 0.487 joules per gram Celsius. If the metal is a pure metal, it's not an alloy, and when you have a literature list of specific heat value, then this specific heat becoming important clue to identify this material. Now a second experiment, same amount of heat is transferred from 98.1 grams of aluminum. Now we know the identity of the metal, aluminum, 0.897 joules per gram Celsius. Now explaining the magnitude of temperature change for the aluminum versus the first metal. Okay, here everything is the same. The mass is same, amount of heat transfer same, mass is same, and the only difference is now specific heat. So aluminum has 0.897 joules per gram Celsius. Aluminum requires higher amount of heat to raise the temperature versus our metal of unknown has, we just calculated, 0.781 joules per gram Celsius. Okay, then let's get started with the heat equation again. Q equals mcat, mass times specific heat times delta T. Here is asking about temperature change. So then we'll be focusing on delta T. So let's divide both inside by mc, then mass cancels out, specific cancels out. Delta T is equal to amount of heat over mass times C. Okay, here the amount of heat is same, constant, and mass is also same, constant. Then from there, delta T is inversely proportional to the specific heat. Okay, so then here 0.897 is bigger. Aluminum has, the C is larger. 0.897 joules per gram Celsius is larger. So then delta T is inversely proportional. Delta T is inversely proportional, so delta T of the aluminum metal will be smaller. This is our conclusion. So in this problem, it was asking us to, do you know how to use the heat equation properly, especially in this simple coffee cup calorimeter. We are using this one to measure the heat capacity, specific capacity of the unknown metal, and use it to identify the unknown metal. And then we are comparing this unknown metal with another metal with known identity of aluminum. And then when you look at the literature, you find that aluminum has 0.897 joules per gram Celsius of specific heat. Based upon this one, can we have relative their temperature change as long as the amount of heat transfer, the amount of the mass of the material is the same? Then this is asking us quantitatively and qualitatively about this heat equation. That is important part. Not only this one, in this problem, I see this is part of free response questions, but many times this type of problem is asked in multiple choice problems. So let's have a thorough review of this problem to get ready for the upcoming AP chemistry exam. Thank you, and I will see you in next video.